Hey, Jody here with weldingtipsandtricks.com. This week's video is about TIG welding some aluminum tubing. It's 3-inch aluminum tubing, roughly 1/16 inch wall thickness. That's 1.6 millimeter wall thickness. And it's a bunch of pie cuts for some type of an intake snorkel for a car. Let's get into it. This is the finished product, all polished up and installed on the car. This is for a company called S1 Built. I'd like to give a special thanks to them for providing the aluminum pie cut material for me to mock up close-ups here while Roy welded this thing out. Now, Roy Crumrine is a friend of mine down in Florida. We've done collaboration videos before, and the way we do that is he does the actual work in his shop, and I mock up close-ups in my shop, and I edit stuff, and hopefully we make a interesting video. But Roy doesn't have the luxury of having the car to fit this thing, so it came to him all taped up. So he can't move it. He's got to tack it up, get it all fit up where point A meets point B without moving it around. So where there's a little gap here and there, he's got to live with it. Now these pieces are saw cut and not a bad finish, but in order to get really good penetration and a good bead profile inside, saw cut is not optimum. These would need to be filed smooth. The problem is, in order to take all the tape off and file them smooth, you would lose the orientation, and with all those pie cuts, accumulation of tolerance, point A might not match point B. So just got to tack them up with the tape on them and hope for the best. These are the machine settings I'm using. I'm using an inverter here with triangular waveform. Now this particular one has advanced square wave, soft square wave, and triangular. And I'll explain a little bit what that is later, and also I'll go over it in depth in future videos. All right, no pulse. I'm using a foot pedal. Got the amperage set about double what I would normally have. AC balance set on 35% cleaning. Frequency all the way up to 250. This machine maxes out at 250 hertz. This is triangular waveform, a schematic of it, sort of. And, it just basically bounces from EP to EN with not staying on each side very long, as opposed to advanced square wave, which has got a dwell time on each side. Well, the thing with triangular is that you lose a lot of heat input while it's making the transition across the threshold here. It's good for really thin metal, but it takes a little bit more amperage. And I wound up using a tapered electrode. This is actually after several beads. It stayed tapered, just barely rounded on the tip. I use a number 6 Pyrex cup with a gas lens and only about 12 to 14 CFH of argon. So this is Roy Crumrine, my friend, doing tack welding, peeling back the tape, trying not to put any more heat into it than he has to, because it's going to gum the tape up, makes it very difficult to wipe off the residue with acetone. And again, since he doesn't have the luxury of having the car there to fit this thing, he's just in his shop. He's got to be careful not to let the thing clock, not to let gaps or try to close up gaps, and just let it not get too much heat in it to where he gums the tape up. Takes a little patience. Sometimes you can't get all the gunk off either, and so this is the way I tack weld, to try to use that cleaning action of the arc before I ever puddle anything. I just walk it around a little bit over the edges, get it clean before I puddle, and then you got to stab it to kind of join the two pieces together to where they'll conduct heat evenly, where it won't peel, one side won't peel back. And then taper off, adding a few extra drops of rod. Now here's that again, another look at it. Again, trying not to puddle it right away until I get it cleaned up, and then stab it to join them, and then add a few extra drops, and then swirl. The swirl. That's the way it's not always necessary. Sometimes you can just hammer shock and get rod in there, but on contaminated aluminum, that's just my go-to method for getting small tack welds. Roy is using a number 5 standard cup here with a water-cooled torch. That's his go-to cup for stuff like this. He prefers that to a gas lens, and a lot of people do, and there are reasons for that. It's kind of a deep subject, but we'll go into it in a future video. I used the gas lens for this particular job, and it worked pretty well, but I use a small one. So Roy's going over all the joints and all the tacks with a stainless steel clean wire brush. You can see some of these joints have little gaps in them, but what Roy did was he tacked them as he was brought it, however it was taped up, because that's the way it fit the car. Now, you notice that steel angle block he's got propped up. When you get an odd shaped part like this, sometimes just positioning it and propping it is difficult. And he saves all kinds of blocks like this, machinist blocks, 1, 2, 3 blocks, blocks of aluminum, in addition to some other, some ball vices and things like that he's got in his shop. And positioning something where you're comfortable and can see it is about half the battle. So he's going to start here just ahead of the tack, not on the tack, because if the tack is stressed and he lights up on the tack, it'll pop loose and he could lose his fit up. So notice how he is rotating the torch as he is traveling, always trying to point the torch toward the middle axis of the tube or pipe. That's hard to do. You can easily get too much angle going if you don't intentionally do that every time you dip rod, to rotate your wrist just a little bit so that you maintain a decent angle. Watching Roy feed the rod here, it looks like he's actually pushing quite a bit of rod in there, and sometimes you just have to. He knows that this is going to be kind of buffed and polished after the fact, so he wants to leave a little bit of a crown so that in case they take a little metal off, there's still enough reinforcement there and everything will be okay. It won't be a comeback and have to add weld and all that. You want to get these things done in one shot without any return work if at all possible. Also notice that he's getting the travel direction of each bead is continually in the same direction. He's having to swap around from joint to joint so he doesn't overheat, because these pie cuts are only about maybe 3/8 of an inch thick in that thinnest part, not thick but wide, and so it would be very easy to overheat and have the puddle wick over and just try to fall out with you if you don't swap around and let things cool. So again, it's a strategic job that requires some patience and some thought and some heat control. I want to show you this here. This is a technique that Roy often uses. He starts off just ahead and then backs up about 2 ripples into the bead to make sure makes a good sound tie-in. So right there starts, then backs up about 2 ripples and then carries on. And that lets things heat up, especially with aluminum, since it's so thermally conductive and the heat changes on you. When you're swapping around and letting things cool, now you're starting off on a cold bead, and so backing up just a little bit can help make a nice smooth tie-in. This is another good example here of watching Roy turn his wrist and let the torch turn to continue pointing toward the center of the pipe as he comes up the side there. Not that easy to do. Takes some practice. Let's see if we can get one more angle of that from a different perspective here. And something else I notice here, the angle that Roy is feeding the rod there is kind of sideways, and that's not what textbooks would tell you. But to maintain his line of sight on the puddle, he's probably doing that just to get a better bead on the puddle. It works. You don't always have to feed the wire at an optimal angle. There are times on real jobs like this when you just do what works. All right, let's talk about the settings here real quickly. I set the amperage to 125 and then just controlled it with a foot pedal. That seems like a lot for that thickness tubing, but I had extra when I needed it to go over tacks and things like that. I was using triangle waveform, like I said, at 250 hertz. AC balance set to 35% cleaning, AC frequency to 250 hertz, 332nd lanthanated electrode, tapered, almost like I would taper to weld with steel. And I use a number 6 cup for the close-ups. Roy used a number 5 standard cup to do the job with. It was taped up, so the fitment and the gaps and all the angles had to be tacked just as is to make sure that it fit. Lots of blocks and vices and things it took to prop this thing up and get it in position to weld comfortably. That's very important. It comes in really handy to save lots of aluminum blocks and things like that for jobs that come along like this. 4 tacks on each joint, and then it was all wire brushed with a nice clean stainless steel hand brush. The direction of travel, even though the welding was swapped around to prevent overheating, the direction of travel kind of was in the same direction to kind of even things out so that it wouldn't distort too much. And then one more thing, all the stops were positioned on the bottom of the part so they wouldn't be visible when it was installed on the car. Just a little detail. Little things mean a lot sometimes. Again, thanks to S1 Built in Clearwater, Florida for supplying the pie cut tubing for me to do this video. I think you can find them on Facebook as S1 Built Clearwater, Florida. Well, that about wraps it up for this week. As always, I appreciate your time. I know you got a lot of choices out there as far as YouTube channels go. I appreciate you spending time on my channel. We'll see you next week.